Recently, I was invited to a group where music lovers, musical equipment enthusiasts, and sellers gather. And I agreed, but I keep a low profile with my opinions. I don't really stand out there. If someone asks me directly, I answer, but mostly I just listen to what people think, what they ask, and how the sellers respond. I'm studying marketing. After all, these are people who are involved in selling equipment. And one offer caught my attention. So someone asked, I bought a good amplifier. What type of connection should I use with the loudspeaker? And I was impressed by the answer, by how the seller responded. The seller replied, you should buy wires that cost about 10% of your amplifier's price. From a sales perspective, that's a clever answer. But what does it not answer? It doesn't answer the question of what we actually need, or what the real requirements are. And here I selected, here's an example. I looked it up, and this kind of cable is priced for a good amplifier. A good amplifier can't be really cheap. I would say that the absolute minimum price for a good amplifier is €1 per watt per channel. So if you have a good amplifier with 500 watts per channel, it should cost around 1,000. And honestly, you can't really make it cheaper. You'd have to cut corners somewhere. Well, I found one here on Amazon. If you look at the cable, it's nice, and the box is nice too. So what's the length? With American standards, 6 feet, that's about 2 meters. Basically, it's short. And everything here is nicely done. Lots of stickers and so on. Will your loudspeaker work with this cable? Of course it will. No problem. But personally, for me, when I look at it, well, what do you think is not quite right with this cable? I'm just pausing. Well, yes, I agree. If you look at the weight of this cable and the pin, there's a problem here. It's a mechanical issue. Of course, at home everything is fine. You connect it and it will work. But if you nitpick, it's unbalanced. It's unbalanced. But overall, it's a decent cable. 2 meters costs 100 there. No, more. 132. But that's what the hi-fi world kind of knows. So what question did this salesman not answer? How much do you need? Or what parameters do we need to have the very best cable? And basically we can take a look at a parallel to hi-fi audio or high-end audio is a recording studio. That's where our recording is born. And the first question is, does a standard exist, for studio quality speaker cables? And here's the first catch. There is no formal standard. This gives a huge opportunity for salespeople and marketers to, do their thing and offer all sorts of things. Because if it were standardized, well, then we would either invest in or fit into the standard and everything would be fine. But there is a generally accepted minimum. Well, first of all, copper. A good copper wire with good conductivity, low resistance, durability and stability. So what isn't used in studios? Of course, we don't use various, exotic materials that, I don't know. Inside one material is coated with copper. That's not it. But the very best silver wires for sound, that's also nonsense. The difference in conductivity isn't that big. We use silver only in high-frequency circuitry where the so-called skin effect appears. Basically, where the useful signal only travels on the outside of the conductor. Yes, in that case, silver makes sense. But in audio applications, it doesn't. And basically, the 3 basic criteria, the electrical parameters, are conductivity and then reliability. This also includes connectors, joints, and noise immunity. These are the 3 key parameters that are considered in studios. And, well, what is the wire gauge? So I found an American one 14 AWG, 12 AWG, and 10 depending on the length. Well, here we only had a 2-meter wire. Yeah, I would say that 3 meters is the minimum to arrange everything properly, and so that the wire doesn't hang in the air. But actually, we can easily go up to 6 meters. The most important parameter here, first and foremost, is that the resistance should be 0.2 ohms or lower. Let's remember that because it's important. If we meet this parameter, we're already very close to having a high-quality wire. Well, I picked out a table for you here. You can check out these AWG conversions. I won't go into detail here. And I picked 14 AWG. What is that in the metric system? Well, that's 1.5 square millimeters, right? 1.5 millimeters in diameter and 2 millimeters in cross-section. 2 square millimeters cross-section. That's what studios recommend by default. And if we calculate it from an engineering point of view, calculate it specifically, knowing that it should be below 0.2 ohms, and what do we get? Let's calculate something a bit thinner. 1.5 square millimeters in cross-section, 6 meters long. This basically fits about 90% of our requirements. 6 meters is enough. That's 6 meters per side, right? We have 2 speakers, 2 wires, so we can spread them out as much as we need in a fairly large room, these speakers, and the wire will lie on the floor and won't be hanging in the air. Let's do the calculations. This is a middle school level calculation. Just a regular, very basic calculation. Here is the specific conductivity of copper. We find it on the internet or in reference books. It's a standard value. Here's the calculation formula. You can review it. We've already calculated it. We get that for 6 meters of 1.5 square millimeter cross-section copper wire, we get 0.7 ohms. Well, since we have a wire going there and back, we have 2 wires. We multiply by 2. We get 0.14 ohms. We're below 0.2. So basically, this 1.5 square millimeter wire suits us perfectly. We don't even need 2. Right? If we have this kind of wire, that's it. I'd say we can use it for almost up to 10 meters per speaker. Well, if the distance is greater, then we take a thicker one. So the absolute minimum you need is 1.5 square millimeters. I would say if we have only, well, let's say 3 or 4 meters, we can even use 1 millimeter. And 1 millimeter isn't expensive, and everything will be fine too. How does this affect the professional market, where these cables are also available? Because it's very hard to figure things out in consumer stores. There are so many statements like that. 10% of the equipment's cost. That essentially tells you nothing about what kind of cable you actually need from a technical standpoint. Well, let's take a look. Here we have speaker cables. These are cables for loudspeakers. There are a lot of them, but I'm interested in the cable's diameter. And let's look at the ones that are common, let's say, as a standard. There is basically one standard, 2 conductors, each with a cross-section of 1.5 square millimeters. Then 2.5, and then 2.5, but more, biamping. If we need biamping, there's also a good option here. Well, then there's a cross-section of 4 square millimeters for very high power, large systems or long distances, and the options are fewer. And if there's a good filter here, let's sort it by popularity. So, price from low to high. Of course, the first ones are very short, which doesn't interest us. But and let's also set the cable diameter here. Let's pick 1.5. That's the minimum required. Let's find the minimum required. And I want to show this one. I do not know much about this manufacturer, but in this professional world, you can't get away with a bad cable, right? See, it definitely works. So it's 10 meters long, costs $16.90. If you cut it there and connect it and put banana plugs there, that's it. Everything's great. Well, if needed, we just cut everything and put other connectors there. Well, basically, it turns out that Well, I'll be a bit pessimistic, but for 20 euros we can solve the cable problem. So that phrase that it should be 10% of the amplifier's cost, well, this one meets every requirement. Let's take another look in case you want to make the cable yourself. Overall, this cable is good. It has flexible rubber insulation, proper copper, everything is fine here. This is for professionals. You buy this kind of cable, prepare it, and you'll have an excellent cable for sound reproduction. A bit of theory about cables. So here I took a nice picture from a reference book. So basically, two separate cables. This is the antenna. This is the worst option. You shouldn't do it this way. If we have a bad amplifier, we'll interfere with others. It will radiate like an antenna. If, on the other hand, our neighbor has a bad amplifier, then it will interfere with our whole system. In general, this is unacceptable. Two closely parallel ones are normal, that's good, but not excellent. Many cables like these, which we buy standard budget ones for speakers. But the best is if you twist them together. And why do you need to twist them? Because then it compensates, it becomes noise resistant. Let's see, here's another one. If you have two parallel wires, the current goes like this, and it radiates, and the current returns. But when we twist them, they cancel each other out. And the magnetic fields that would radiate interference cancel out inside. That's why a twisted cable is very good. And here I want to show you a few examples regarding connectors. Because in that amateur environment, there's some kind of complete nightmare. Understanding what works and what doesn't. And we can actually sell various expensive things where they're not needed. This kind of connector for loudspeakers is used quite often, and from my point of view, it's good. First of all, these two plastic parts reduce the chance of a short circuit. Basically, they reduce the chance of a short circuit. If these are metal, you could get a short circuit. Here I have a classic twisted cable. And what do you think is the most important thing about this connector? Yes, maybe it has a very good coating. That's one part, but it's not as important as how good the spring is. The better the spring, the less it wears out over time. See how it fits in, right? It holds on so tightly, it makes a solid connection. And here it's impossible to measure the resistance with a regular device. It's very, very low. It holds on really tightly. Basically, in the professional world, banana plugs aren't used, or they're used rarely. In that case, they must be good. Well, overall, what do you think? Is this design good? It's cheap stuff. Well, yes, from an engineer's point of view, it's a good design. This part is insulated. This is insulated too. If we sometimes need to, well, I don't know, measure something or do something extra, there's also an option here to make good connections. I can take different measurements. The contact itself holds firmly. It's good. And the cost for such connectors in large quantities is very low. I would say even in a store, if you go to the catalog and buy a couple, they will cost from 1 to 2 euros maybe. But in the amateur or high-end environment, this part can cost $40. And this cable, as you saw, costs $132. So you can save on this if we understand. Sometimes it happens that we bought expensive equipment, used a cable like this, and we keep thinking that because of our cable, it could sound even better. And at night we can't sleep peacefully. Sleep peacefully, if you have this kind of connection. There are definitely no problems with the sound, definitely none. So, how is it in the professional industry? In the professional industry, basically, there is only one. No, actually, there are two standards for connecting to speakers. But I'd say that only one is good. There's also TRS. But that connector is less reliable. And I would say if you're connecting speakers, you should connect them with speak-on connectors. Yes, it has a latch. And there are also options with 2 or 4 contacts. So bi-wiring is also possible, bi-amping is also possible. You just buy one cable, connect everything, and it's great. So the polarity is always correct. It holds firmly. It opens easily. Overall, it's good and reliable. What's the difference between such an expensive speaker and a cheap one? We have 2 areas of use. One is studio, that's home use. And there a cheap one is suitable because we connect it, then listen for a month, and only remove it sometimes when we make some changes. But there's also concert use, and every day we go to a different place and connect and disconnect all the equipment. And then we have a lot of these connections. They're in the damp, in the cold, in the heat. They always have to be reliable. They're designed for that. If you go to a store and buy something there for, I don't know, $2.50 for, well, it's hard for me to say, for $14. You don't need the one for $14. You have a studio application. Mostly we work in normal living conditions, and there the cheapest one is suitable. It will be good. It has a strong, reliable contact, I would say. What if you have a multi-channel system? Well, for example, you made a speaker, and the speaker only has drivers, and all the drivers are connected to one plug, like this one. Here is another speaker standard. It's quite new for connecting 4 pairs, 8 wires, 4 pairs, and basically it's the same. So, if you did everything right, and the wire is correct too, you won't have any mistakes between what you connect to the tweeter and what you connect to the woofer. It's also very, very good. Overall, the industry is moving forward, and I think many things should be learned from professionals. Here, such dumb marketing doesn't work. People understand everything, they have basic knowledge, they are educated, and in this regard, we need to learn from professionals. When many things are unclear, just look at another industry, look at the professional industry, see how it's solved there. Yes, and you can roughly transfer that to the amateur, hi-fi, high-end, and so on and so on. Because sometimes even the sellers themselves don't fully understand how these things work. There's no mystery here. Everything is perfectly clear. Everything is perfectly clear. Since we're talking about cables, we have 2 cables. One goes to the power amplifier and speakers, and the other goes from the preamplifier to the amplifier, or from the digital to analog converter, or from the streamer. It doesn't matter. In the end, we have a cable going from the preamplifier to the amplifier. It could be a home theater or anything else. We have 2 types of connectors. We have the so-called unbalanced, and we have balanced. Unbalanced means we have one hot wire for one channel and a shield, and the signal is transmitted between the ground and the hot wire. And what do we get? Along the entire length we get interference. Especially in the modern world, we have a lot of electromagnetic noise, and it gets picked up along this length. Here we have low resistance. It's 100 ohms. That's important, right? Low resistance and 100 ohms. Here we have high resistance at the receiver, somewhere between 10 and 100 ohms. We make a choice. If we select a very high input resistance, it means more noise is added. At a lower value, the noise is a bit less. The standard values are about 10 ohm, 20 ohm, up to 40. But there is also other equipment. What do we get? Here we have a normal signal. Noise is superimposed on it here, and here we amplify it, amplifiers. So we get signal plus noise, and there's nothing we can do about it. So here basically we can work, I would say, up to 10 to 20 feet at most. In general, a standard cable is about 5 feet long, and there are even whole legends about how it's made. But that's the point. And the second one is a balanced input, or a balanced principle. And here we need to understand why it's good. So we also have a source, but we create the sources artificially. We use 3 wires. We have one hot wire. It's in the positive phase. The second one is also hot, but we supply it in the negative phase. And we also have a shield. The shield works like a Faraday cage. It protects these two hot signals. So the audio signal doesn't go through the ground. In no way. And what do we get? They also go through long lines and noise is added. These are in antiphase, but the noise is added in phase. And we feed it into a differential amplifier, so the positive gets amplified. The one that's negative gets its phase inverted. And it gets summed up, and we get double the amplitude at the output. And as for the noise, since the noise on both wires is in the same phase, it gets subtracted and cancelled out. But if you do it really well, you can get approximately noise suppression of 25,000 times. That's the theoretical maximum. You can achieve it with properly made input transformers and with very precise input summing amplifiers. This principle isn't new, but professionals use it. What benefit does it offer? This gives us the ability to transmit a microphone signal over a long distance through a cable. And if we take the amplifier into account with good engineering, we can transmit up to 600 meters. In practice, we transmit from 1.5 up to, it's hard to say, up to 25 if it's a very large room and in a circle and so on. This gives a big advantage. When you buy modern digital to analog converters in modern equipment, then choose a model that has both standards. This also gives you the opportunity to use professional cables, and professional cables are very good and inexpensive. Let's take a look at some of these cables. Here, I took this cable. It's an adapter. This isn't the one you can use to run over a long distance yet, but with this one, we can just look at the connectors. I'll show you later. This is a standard connector for consumer equipment. It's also made neatly. This is a good connector. I use this type in my own projects where it's necessary. Well, in general, for this kind of studio use, everything is fine. For studio use, everything is more or less fine. Well, let's take a look at a professional connector. In the professional industry, there are only two connectors, this one and TRS. TRS. That means it's big, all the contacts are big. It's the same, it has a lock, it closes, it doesn't fall out. Even if it shakes, it still doesn't fall out. It's a very reliable connection and it works well. And in the professional world, there's the microphone cable. They're produced in incredible quantities. Half the world manufactures them. You can buy a very well shielded cable for next to nothing. Why is it so good? It's designed for microphone level. Can you imagine microphone level compared to the signal level you need to send to the amplifier? It's 100 or even 1000 times lower. So these parameters are much higher than what we need for our application. And when we connect them, everything is fine. This is a very good cable. And let's see how much these very, very good cables cost. Any such cable is much better than the most expensive RCA cable. Those cost crazy money, but this one is better. Well, let's take a look at the microphone cable, a 10-meter microphone cable, and see how much both connectors cost. 11 euros. And it's very good. It's pretty good. But let's look at something cheaper, and the absolute cheapest, well, this one is too short. It's way too short. 30 centimeters is too short. We need about 6 meters. Let's see how much the shortest one costs. No, we don't need 6 meters for connection. Basically, we only need a meter, well, 1.5, yeah. Anyway, there's this big manufacturer. They make it for half the world. So Snake, yeah, 550, that's it, 2 cables. So the lowest level of our cable requirements is 550. If someone asks you for 60, that's fine, but you can also get them cheaper. Well, if we sum it up, basically if we understand everything well about cables, we can save money. But let's imagine that we have this money in our budget. We've planned for it. Where should we move it? I would say that everything we can save should be moved to the speaker, because the speaker, first of all, determines about 90% of the sound, and the speaker lasts a very long time. If we do manage to save up the right amount of money for the speaker, then we'll be able to listen to good music. Everything else can be picked up later. Some things are changing, many things are becoming cheaper. The amplifier is getting cheaper, digital sources are getting cheaper, converters are getting cheaper. We're not losing quality, but the speaker is the most important thing. So let's save up money for the speaker.